The solution to this problem is so simple, it's self-evident. This is 2869 minimum operations to collect elements. So this is an easy, and it's pretty easy. So let's go ahead and get right into it because I don't have a lot of time today. So I want to just approach an easy problem and maybe just give a little bit more information on, how do we reason through simple problems to try to compartmentalize information, right? Segment things, think about, all right, we have to do this step, we have to do this step, we have to do this step. Since this is such a simple problem, I'll spend more time on each of the, independent kind of structural components of the code that will help you realize the solution. Okay, so you're given an array nums of positive integers and an integer k. What does that mean? Okay, so if you're given this information, that information is provided as an argument to the function, right? You're given nums, here you see nums, you're given an integer k, and voila, there's that integer k. In one operation, you can remove the last element of the array and add it to your collection. Okay, so I'm creating some collection and I have to remove things from the right? Remove the last element of the array. So I can remove this 2, then this 4, then this 5, then this 1, this 3, right? I'm going backwards through the array when I traverse it in terms of removing elements and adding it to my collection. Okay. We're going to return the minimum number of operations needed to collect elements 1, 2, ... k. What does that basically mean? 1 through k. So how long does it take for me deleting elements from the right to collect 1, 2, 3, 4, 5, 6, 7, all the way up to k, whatever k is, okay? So in this example, we have nums equals 3, 1, 5, 4, 2, and k equals 2. So we're starting with nums equals 3, 1, 5, 4, 2, and k equals 2. So what does that mean? Well, I'm trying to make a collection of 1 up into k. So if k is just 2, my collection is just 1 up into k. So 1, 2, that's it, right? Now what I'm trying to do is I'm trying to collect 1 and 2, deleting things from this array. So first I have 3, 1, 5, 4, 2, right? And I collect 2, so I remove that from the array. And now I have 2 in my collection. So now my collection equals 2. Then I remove 3, 1, 5, 4. I have a 4. And I guess I can add that to my collection, but one way of also thinking about this is if this isn't going to get me 1 to k, I might as well just disregard the 4, right? Get rid of the 4, but I'm not going to add it to my collection, right? Because I'm trying to collect all the elements from 1 to k. 4 is greater than my k value too, so I'm just like, I don't need it. Useless. Pointless for me. All right? Then we do the same thing with 5. We just disregard it. And then we remove the 1. Right? Of course, at each of these steps, my collection is still just 2. Right, because I'm just kind of making the choice of, well, logically, right, if I'm just trying to collect everything, if I'm just trying to collect 1 and 2, getting a 4 means nothing, so I'm just going to throw it away. So my collection stays 2 up until this point until I see this 1, and now my collection is 1, 2, and then I'm done. So how many elements did I have to delete to make this happen? I had to delete 4, so the output is 4. All right, so that's one example. Let's go ahead and quickly do another. All right, so k equals 5. So my collection, I want to collect 1, 2, all the way up into 5. All right, so now I have 3, 1, 5, 4, 2. And my collection is nothing. And I'm going to keep 2 because I look at 2 and say, oh, 2 is good. I want 2. I'm going to add that to my collection. All right, so I'm going to remove 2. I'm just going to do it, on the same line here. So I look at 4 and I say, oh, look, 4 is good. I'm going to add it to my collection. Now, how we actually put this in our collection, we'll discuss those details in a moment. Oh, 5, that's good. Add it to my collection. All right. Oh, 1, that's good. I'm going to add that to my collection. All right. And then finally, oh, 3, that's good. I'm going to add it to my collection. And just like that, I have everything I need to make this work. All right, and that took 5 steps, right? Because I had to empty the whole array. There's 5 elements, so the answer is 5 here. All right, now one thing that's given is that you can always collect everything, right? In this case, it was like the exhausted case, right? Because I had to look at literally every element to create my collection, but you can always do it, right? So that's just something to note. Now, with this being 50, it's very gracious in terms of what our solution would be, right? 5 times 10, so 5 times 10 to the 1. So we could have like an n cubed, maybe even n to the 4 power solution, it would still pass. But, let's try at least to make this thing efficient. Even though the constraint is so lax that, you know, we could really kind of do whatever we wanted. All right. So how will we go about this? Well, first thing, right, is that we remove the elements in reverse. So we should probably create a mechanism to traverse the array in reverse, right? I want to remove this element and consider it, then 4, then 5, then 1, then 3. So in order to go through an array, of course, we're going to use a for loop. And now in Python, we want to start at the end of the array and then go backwards. So the last element in the array is length of nums minus 1. And then that's the last element in the array. That's the first thing we're going to look at. And the very last element we're going to look at is element 0. But that would mean that we stop at -1 because we're going to go all the way up to -1, right? We're going to go to the last element and then go backwards and stop at 0. So the next element after the last element, exclusive, would be -1. And then we're going in the negative direction. So that's kind of how these loops work, right? Your starting element, your ending element, exclusive, and the direction you're going, right? So in kind of mathematical notation, it kind of looks like this, right? So we go from the length of nums minus 1 all the way to -1, to 0, to -1 exclusive, which is for, you know, integers, that would be 0 inclusive. So we're going from the end to the beginning. That's what this array does. And just to confirm that to you, right, if I do print index, we should get 0, 1, 2, 3. So get 4, 3, 2, 0, 4, 3, 2, 1, 0, 4, 3, 2, 1, 0. And then, you know, if you wanted to get the element of that array index, you get 2, 4, 5, 1, 3. Right, so that's 2, 4, 5, 1, 3. So it's processing this in reverse like we want. So that's taking care of this idea that we're going in reverse, okay? Now, the next thing is, well, kind of when I was doing that example, right, it was like we kind of disregarded things, right? We looked at things and said, you know, this element, for example, when we're looking at k equals 2, we're just trying to collect 1 and 2. So when I'm given a 4, I can disregard that, right? If anything's greater than my k value of 2, I might as well not look at it because it's not going to give me any additional information. So maybe we should add that in here, right? If the value, nums of index, right, that's the value that we're looking at, we're only going to care about it if it's less than or equal to k. If anything, if it's within this boundary, right? Because anything else is just stupid, right? It's not useful to us. This 4 value does nothing to our solution. We just know that we have to take it off in order to look at it, but we're not going to add it to our collection because our collection is just up to k, right? Our collection is from 1 to k. Anything else, we disregard. So I'm just going to put this if statement to say, well, I'm only going to look at the things within this range, right? I'm only going to look at the things from 1 to k, inclusive. Anything else, I'm just going to ignore. So I'm going to make an if statement to ensure that I'm only dealing with things within this case, right? So now if I print, you know, nums of index, you know, it's only going to print the 2 and the 1, right? Because the 2 and the 1 are the things that I'm looking for. And then you might say, well, every time I'm in here, right? So that's, you know, we got the kind of form here, right? We know how we're going to traverse this array. And then we also got the idea of kind of filtering out the elements we don't want to look at. So we're only looking at the elements we want to look at. We might say, well, 2 and 1, right? I just want 2. I just want 1. Well, every time I'm in here, I'm collecting something, right? So every time I'm in here, I collected another element. So maybe I'll keep track of the number of elements I've collected, right? And how many elements do I need to collect? Well, I need to collect k elements, right? So if I've collected k elements, so if collected equals k, then I'm done, right? That means that I've collected 1, I've collected another. So every time I'm in here, I just added to my collection. So as soon as I collect all the elements, right? As soon as I collect all the elements, that means I've collected k elements because I've collected 1 through k, right? 1, 2, 3 elements, 1, 2 for 2, whatever. So I've collected all k elements. I can return the answer. And how many did I have to collect in order to get here? Well, I'm going in reverse, right? So you might be saying, well, how many did I have to collect in order to do this? Well, that would just be length of nums minus the current index that you're at, right? So, well, if you collected 1, you'd be here. Yeah. Because, you know, for example, if you only... Leetcode Premium. No, I don't want Leetcode Premium. Maybe someday, but not today. Okay. I is not defined. Oh, because I called it index. Right, and I guess the way to make this work, right, because you're going to see this work here. Of course, this isn't the final answer, but just to help you here, right, what is the length of nums, right? If this is nums, the length of nums is, well, you just count the number of elements, right? There's 1, 2, 3, 4, 5 elements. Okay. Now, this is index 0, 1, 2, 3, 4. I'm just trying to write this out so you can see how this is the kind of the answer for how far you go, right? Well, this thing is done when I get here, right? When it collects here. So the index would be 1. So how many elements have I collected? Where the length is 5, I've collected 4 elements. That's just the length minus 1, right? I've collected 4 elements in order to get to this 1, right? I had to collect this 2, then this 4, then this 5, then this 1. And how many in that in total did I collect? Well, that's 4. So that's just the length of the array minus the current index that I'm at. I hope that makes sense, right? And if we had to collect all the elements, right, there's 5 elements, 1 offset. So, you know, you can walk through this, but that's kind of how I like to think about these things, right? I literally just, you know, plot out, okay, what are the indexes? What is the length? What is the relationship here? Well, I know I collected 4. Oh, it's just, well, the length of this thing is 5, and I'm at index 1. I collected 4. That's 5 minus 1. So that's length of nums minus index. Right, and you can see it here even easier, right? Imagine that you only had to collect 1 to get the answer. Well, at this point, how many have I collected? Well, just 1, right? Well, that's the length of the array minus 4, 1. All right. Maybe I'll... So then maybe you might say, okay, well, this is accepted, so let me just go ahead and submit. Now, this is not going to work because what? Well, the problem here is like, just because I've added something to my collection, there are repeats here, right? So the problem with this approach is it doesn't account for the fact that I might get a repeat thing that I've already added to my collection, right? Every time I get something that I collect doesn't necessarily mean that I can add it to my collection, right? Here I get a 2 and I say, oh, I'll add a 2 to my collection, right? Then here I get a 2, and instead of saying, oh, wait, I've already collected a 2, right? I've already added 2 to my collection. I try to add it to my collection again. So then I think, oh, I've collected 2 things. That means I've collected k things, and I return nums. But really what happened is I just collected 2 twice. I can only collect an element once. I need to collect all the elements in the range, right? I don't count the same one twice. That means I have to collect all the elements in the range once. So I don't want to overcount, right? I don't want to say that I've already collected an element, right, I don't want to say that I've already collected an element and then try to collect it again, right? So this doesn't work, right? This only works if I'm only given unique nums, right? This worked in this example because all the numbers were unique, so I never overcounted, right? I never counted the same element and said, oh, I collected that already, right? Because what I'm trying to do is here, I'm trying to say, okay, every time I'm here, that means I'm collecting a new number. And as long as I've collected all the new numbers and I've collected all the k values that I need to collect, right? But if I'm given a redundant value, that's not going to help me. Giving a redundant value is just going to give me a value I've already collected, so I don't want to account for it. So basically what we want to do is somehow not account for things that we've already collected. Okay? So the way we can do that is say, well, you know, let's just say that, let's instead call this total collected. All right? And then we'll have a collected array. So we can make it a set or an array. And let's just say this set, right, and not and nums of index not in collected. So we don't even need this total collected anymore. Or I don't want to do too many things at once. Okay, so collected add nums of index. Right, so now what I'm saying is only account for the new thing, right? Only account for the new number if we haven't collected it already. Okay? But now what you can say is, well, then do we even need total collected? Right? Because collected, the length of collected will now account for the total number of elements that we've added. So we don't actually need that. And voila, there you go. Now we could get this a little bit faster if instead, you know, we did do it this way. I'm not going to go down that rabbit hole, right? This is a constant operation. This is a constant operation amortized, and we're just going to stick with that. Of course, you could use an array here because n is so small. You can keep track of all the k values, whatever, but I'm not going to go down that rabbit hole. This is fine. It's an easy problem. The fact that this is 7%. It's not making me irritated. So n equals length of nums, okay? And then k is k, of course. So for time, well, we look at every index in the range. So we might, in the worst case, have to exhaust every single element in order to create our collection. So that's going to take n time, right? We have to look at all n elements. For all n elements, this is asking if something's in a set, that's a constant operation. Asking if a value is less than another value, constant operation. Adding it to the set is an amortized constant operation. So these are all constant operations. And then length of collected equals k, constant operation, returning, subtracting two things, constant operation. So for n things, we do constant operations. So that's big O of n time. And then for space, a little bit trickier, because for collected, we only keep track of the elements that we collected that are less than k, right? We only ever add something to the collection if the value is between 1 and k. Otherwise, we don't actually grow the set. So the set is only going to grow with elements within the range 1 to k. So the set's never going to be greater than k. All right, that's it, guys. I hope everyone has a great day.